Montclair State University is the second largest university in the state of New Jersey. We have over 21,000 students on campus. We're currently at about 5.4 million square feet under roof. Around 2012, the decision was to move forward with the construction and installation of a brand new cogen facility that supplies the entire 5.4 million square feet of the university campus.
I'm Kyle Gandy. I'm the electrical engineering manager for DCO Energy. DCO was partnered with the university to build a new central plant on this campus. Within that plant are chillers and boilers and generating assets. And then we send and distribute out to the campus steam and chilled water that's heating and cooling all of the buildings that you see on the campus.
And we've been able to be extremely efficient. The plant operates upwards of 80% efficiency. So building on that success, we began to discuss what our next steps were from an energy standpoint. We came up with the idea of potentially installing a microgrid. Folks will claim that they have a microgrid because they put a set of solar panels on their building, or because they put an emergency generator that backs up some of their critical systems. And that doesn't meet the true definition of what a microgrid is: to provide redundancy, reliability, and that seamless transformation from local utility back to our own generation power, and be able to couple and blend multiple sources of power to ensure that level of reliability and redundancy for our campus. And so ultimately, DCO, along with Montclair State University, selected SEL because they just had the strongest package, and they certainly seemed like the corporation who was going to put this together for us.
When we were doing our due diligence as DCO, when we were interviewing, some of the questions that we were asking, one being, how are you going to manage VAR, reactive power control, in island mode with multiple generators from different manufacturers? And that's what we have here. That's a question that stumps a lot of people. It did not stump the technical folks from SEL.
So the SEL microgrid philosophy is to basically use SEL relays, right? Those are our primary protection, but they also provide some high-speed information that we need to detect contingencies. On this particular project, what we utilized was a 751 relay at the point of interconnection with the utility, and we used the fast rate of change of frequency element, 81 RF, which helps us detect utility disturbances at a faster rate than a traditional under frequency or over frequency element. So that helps us to quickly detect an anomaly or a disturbance on the utility, trip the point of common coupling breakers, separate the university, and actually do load shedding.
If the local utility were to go away instantly, that system makes a decision. It divorces us from the utility to protect the campus. It then looks at the buildings on campus and the campus load, and it makes a decision to open the breaker on the buildings that we consider to be of the lowest criticality. It hedges us down to 80% of the capacity of the turbine to ensure that the turbine isn't infected, and so that 80% of the campus will still stay up. And at the same time, it dispatches a command to the microgrid engines to start up, warm up, and prepare to power the campus. And then within a few short minutes, it begins to close those breakers back in and bring the campus back online.
When the utility does return, whether it's an hour later or 3 days later, we can seamlessly transition back to utility, and the campus has no idea.
It really provides a level of reliability that we've never had. What we set out to do was create a system that was no longer dependent on what the utility system was doing.
And that's really the heart and soul of a microgrid, is when you lose utility, can you still maintain voltage and frequency and sustain the load on the campus? And that's what we successfully have done here at Montclair State University.